In this video here, we're going to see how to find the point of intersections of a circle and a line. Based on example 2, they ask us to find the points of intersections between the circle x squared minus 2x plus y squared minus 4y equals 0 with the line y equals 2x plus 3. So to solve these questions here, these examples here, I will begin my solution such that first I write down the equations of the circle and I state it as equation number 1. I state the line equations, and before you state the line equation as equation 2, I will suggest that you make sure the equations of your straight line, you have it rearrange it in such a way that you have either y in terms of x or x in terms of y. But in these questions here, the line equation already written as y in terms of x. The reason why we want to have such arrangement before we denote it as equation 2 is because the next step, what we're going to do is that we're going to substitute this line equation into the circle equation to reduce the variable in the equations. Now you can see both of the equations have the variable x and y. And the next step, what we're going to do is that we want to substitute equation 2 into equation 1 so that it will turn out that by the time you substitute 2 into 1, all the y term in equation 1 will turn out to become 2x plus 3. And the result you can see from this is that it only left with the variable x, y is gone. So if left with only one variable, it will be easier for us to solve and find out the result. So as a result, next what we're going to do is that we're going to expand 2x plus 3 squared and minus 4 multiplied with 2x plus 3. So as a result, by the time you expand 2x plus 3 squared, we have the result as 4x squared plus 12x plus 9. On the other hand, by the time you expand minus 4 multiplied with 2x plus 3, it gives us result minus 8x minus 12. And next what we're going to do is that we're going to simplify the equation. It gives us 5x squared plus 2x minus 3. And let's see how we get this answer here. The square terms, we add up, it gives us 5x squared. The x term, minus 2 plus 12 minus 8, it gives us positive 2x. And lastly, plus 9 minus 12, it gives us negative 3. So we have formed a quadratic equations, and these quadratic equations, before you factorize it, try to check 5, 2, negative 3. We try to check the coefficient of the x term as well as the constant, see whether is there any common factors or not, before you try to use your calculator to do factorizations. So in here we don't have any common factors. We will proceed with factorizations. We have the factors 5x minus 3 multiplied with x plus 1 equal to 0. And from the factors, we can find out the x value, x equals to 3 over 5, or x equals to 1. Sorry, x equals to minus 1. And this x value is actually referred to the x coordinate of our intersection points. Once we have done with finding the x coordinate, which is the x value that you see here, now we try to find the y coordinate by substituting each of this x value into the linear equation you have in equation 2. So we substitute 3 over 5 into 2x plus 3. We substitute minus 1 into 2x plus 3. And let's see what we happens to obtain. Substitute 3 over 5 inside equation 2. We find out that we have the y equals to 21 over 5. Substitute negative 1 into equation 2. We have y equals to positive 1. And now we get both the x and y coordinate of the points of intersections. we can state the intersection point now, where the intersection point is happen to be. So we group the xy, where x 3/5 with y 21/5. We group them together. It will form one coordinate for we will form one of the coordinate of the intersection point. We group -1 for x, +1 for y. It will form another intersection point. And as a result, this is what you happen to see. You group 3/5 with 21/5. So there goes one of the intersection point. Then you group -1 and 1. It form another intersection point. So that's it, how we happen to find the intersection points between a circle and a straight line.